Good afternoon, everyone. Today in this video, we'll learn how to make a simple plastic cover with snap fits and other fits as well. As you can see, this will be a combination of both modules, which is surfacing as well as part module. In surfacing, we'll be using wireframe and surface design and generative shape design. Now, as usual, as our video goes, let us see the drawing first. There are two views shown. This is the front view, this is the top view. There are a few dimensions shown for the internal features as well as the shape. Similarly, when I scroll down, there are three more views, four more views. One is the detail view for the snap fit, and other are the detailed views for the cuts as well as the supports which are in the plastic cover. This is the section view for the internal features for better understanding of the internal features. There is also another section view which is cut over here for us to understand the internal cuts, which is the semicircle cuts, etc. So let's start making this model. We'll go one step after the other. It's a plastic cover. To achieve these kind of shapes as well as rounds, we'll use surfacing module so it can maintain the shape perfectly. These cuts are also made on a surface. As you can see, they're projected onto the surface, which is your circular shape, which is in your circular shape. Now, to begin with, under start mechanical design, since you're working on surfacing, I'll be using wireframe and surface design. While using wireframe and surface design, it is important for us to make the sketch first and then work on it. So let's try to make the sketch. The whole wireframe and surface design works on your points, your sketches as well as your lines. So understanding that, let me try to take a line here and then mirror this onto the opposite side. I am trying to make this shape and then later remove these off of the existing surface. Now I do have two lines and I do have the distance between both of them. It is as 50. Now I require arcs over here. And this is actually supposed to be 60. You can mirror this onto the other side because since we have not maintained the mirror on the lines, you can trim off the unnecessary portions and keep the shape as you can see. The other important dimension they have given is the overall length from arc to arc is 56. So let me try to take the overall distance from arc to arc as 56. This is the actual shape for the base of the plastic cover. Now once I exit, to add material you can use extrude, which adds it in a form of a surface as you can see. The reason again why we are using surfacing and not part modeling or a part model is to achieve these kind of shapes or these kind of cuts. It is impossible to do when you're working on your part model. You might not get the exact shape. You might get some shape but not the exact shape of the cover. So this is only up to 12. So I'll just take it up to 12. The other ones are for your fits as you can see. Okay. Okay, now by this we can understand that the bottom portion should be filled. As you can see, there is a section over here which has material. Before that, let's try to achieve this shape and then slowly do our further commands. Let me try to hide this and start making my sketch. And this is my reference which I'd like to use to do so. And then start making my arc. You can change it to the top view. I am comfortable doing so. So this is the dimension for it, which is supposed to be 15. As you can see, it's shown over here. And the center should be lying on this center. The dimension between these two is supposed to be 20. Again, it's given over here. So once you exit, you can add material to this. I am adding it similar to the base, so you can trim it off very easily. And I'll be using a simple trim command between surface and surface because that's an easier option to do the trim. I can mirror the sketch using a simple mirror symmetry command onto the other side and perform the same operations like I have done before. You will not be able to do a trim mirror. So I am repeating the whole thing again. But while doing an extrusion, it will ask you for a direction. You can just provide it with respect to your plane or your axis. Now let's try to trim again. It shows you this feature. Since I've already mentioned that the base is filled, let's try to use a fill command to completely fill the base. So you can directly fill the command over here, or you can directly take a curve and also fill it. You can take a curve directly with respect to your point continuity and say OK, it will automatically fill the base. Since you are in surfaces, you cannot convert one surface into solid and then come back and convert one surface into another solid. The conversion from a surface to the solid should happen only once. It cannot happen multiple times. In only in rare conditions that does happen, but in this plastic model it does not happen. So to do that, we can join both the base as well as the shaped feature and say OK. Now this will be one single surface. Before proceeding ahead, there are few rounds. So we'll be giving those rounds in your generative shape design because the rounds are there in that option, which is called your edge fillet. So there are different fillets for all the edges. I have four edges over here. As you can see, there's R4 for these edges, but whereas at the bottom, as you can see, is R5. So let me try to give R4 for these first and then try to give R5 to the base. It is necessary that you give all the rounds before converting it into a solid, not after, because when we add thickness to the model, the round does not take place exactly as it is supposed to. It might break the sheet. Now going back, converting this into a solid, I have no other operations left to perform in surfacing. So I'll go back into my part design and I'll convert it into a solid. If you don't convert it into a solid, you can see that none of your operations actually will get highlighted except for addition of new materials. So let me try to convert that into a solid. We know that the thickness is 1, so 1 is already given, and say OK. This is your solid model. From here, it's very simple to work on. It's pretty much like how you work on your part modeling. You can start working on it one step after the other and see how things go. Firstly, let me try to add these circles. As you can see, the 7 dia circles. These are of actually thickness 0.8. All thicknesses are actually 0.8. So I'll make these 3 first and then start adding. These 3 are in line with the face, that is this face. So I can directly create a pad and start. Let me start by making these circles. I can use the direct pad command and then start working on it, considering the top view. And let me go back to the top view so it will be easier for us to work on it. And I have a circle first. I have 3 circles. Let me try to place those 3 circles and then start dimensioning them. They're pretty much of the same dia, which is already shown over here, which is 7 mm. So I'm taking this is 7, this is 7 2. This is 7 2. Now let us try to constrain every single circle with respect to the dimension. That is, this is the first dimension which I require and this is the constraint which I need to give. The second dimension will be the distance from here to here. Horizontal distance, I'm so sorry. I need both anyway. This is 9 and the distance between these two is supposed to be 5. Similarly, the distance from here to there is 16, which I'd like to give first. This is supposed to be 16 and the distance from here to here is also 16. Let me try to give that too. These are all constraints, so once I exit you can see it adds material. I want it to be added up to the next surface it can find, so it will add up to the immediate next surface it can find. Now these I want to use a thicken option. There is something which is called thin pad which you can use. When I use thick, it starts giving you a thickness. The thickness is 0.8, so I'd like to use that because the whatever you're trying to see are actually 2 concentric circles. So instead of making 2 circles, I am giving you a thickness option. There are other supports which are being used as well. So let me try to give those from the top. This is one support. It's a very important one. It's over here, as you can see. So that support I'd like to give from the top since it's already understood that it's from the top. I'll be using these two as my references first. and then I like to make a straight line. We know the distances for all those, so it's actually pretty much okay for us to work on it. We know that the center is 0, 0, which is this. So I'd like to dimension this from the center, because for us the dimensions are given from the center. This is still 12. So once I exit, it will start adding the material from the top, and the 0.8 is your rib thickness as usual. So this will be a support. From here there are various supports which are added, but the supports, as you can see, are not added from the top. They are added from a certain distance from the bottom, which is at 9. So before going further, we'll take the 9 plane and then start our supports. And before going further, let's finish making these small circles, which are at a distance of 14 from the base. So we need to take a plane anywhere. So from here, it is at a distance of 14. On this, we have to make the addition of material. That is up to the next. We already have 3 circles. You can use these references first. And now we can start working on your circles. This is the center of the circle. You will automatically get it. Similarly, you get the other center here to concentricity. Other center here too, again it will maintain concentricity. It takes the auto constraint by itself. All you have to do is dimension it, and you can see if it is green or not. It is automatically green. So let me try to take this also, and let me try to take this as well. Now these should be added up to the next. Since there is a chamfer operation, I'd like to give the chamfer operation a little later. Let me try to add these ribs first, and then maybe work on the other one a little further on. These, whatever ribs you're trying to see, they're actually from 9 mm, as I have already mentioned before. So let me try to take a plane from the base at 9 instead of 14, of course. On the new plane, which I can see, I like to create supports. Again, supports are from stiffener, again from the new plane, and start working on your features. I'm just trying to rotate the view. Now, there are one here exactly at the center location. So I'd like to use both first, and then start. There are one here, not there, sorry. I'd like to use these first. Let me try to give all the references possible and then start working on it. Now, there's one line which actually starts from the center and joins this. There's also another line which starts from the circle and joins the other circle. Now, we do know the distance for this particular one. It's actually supposed to be 3. I think it's given in this drawing. It's supposed to be 3. So let me try to take that from here to here as 3. The dimensions are actually given from the center, so it's a little more easier. Now there's also another support here, that is from the end till here to the center. I can use references also if necessary. I rotated the component. There you go. Now this is the line which I'm going to create. This is one support. Once I exit, it tries to create. We need it actually from the top, so it starts creating from the top, and it is 0.8, so obviously it tries to create it. There are 2 more supports exactly at the center over here, which will be in the front. So let me try to take the same one, but from the side and in the center. Now I'd be using my references. Here I can work on mirror command. So I'd be working on the mirror command easily rather than taking so much pressure of repeating the whole thing again. Let me go back to the normal view and start making my sketch. My sketch actually goes this way. Since it's supposed to start from 9, we already know that the 9 mm plane is this. So I'd like to coincide the line on the plane instead of repeating the 9 dimension. And the overall thickness of this is given in the second sheet, which is 6. So I'd like to take this as 6 and exit. This creates a support again as 0.8. I can mirror this same stiffener onto the other side. It's a little more easier for me to do this. Now, same way I have a support here as well. So let me try to do that too. Again, I'm using the same support, again using the same plane, taking the front view. I need to use this reference. I don't think I'll get it perfectly. I got it. And the base, of course, the base. Now, when you work on the base and stuff like this, it is necessary to understand how the shape is. The shape actually is not from the top, it's actually from 9 and it goes till assuming there. I'll check for the length. Let me try to coincide this first. And the length is actually 13, as you can see here, it's 13. That is from the end of this, it's actually 13. So to give a dimension, I'll use this reference first, and then I can start giving the dimension from this to this as 13 because that is the end for me. And once I exit, it tries to create a support which is again of 0.8 only. These are my supports. Rest all can be added. It's not a big problem. You can use pad and start adding the material depending on where they're starting from. All of them actually start from 9, which is this plane. So you can make all of them in one go and work on it also. If you're not comfortable doing so, then just you can do it multiple times. I'm using it on the 9 plane, as you can see. Now the first one I'd like to add is over here. This is my reference. Now the first one I'd like to add is the small rectangle over here, which is towards the inside. I'm taking a rectangle over here towards the inside. And I'd like to maintain symmetry with respect to the center first and then start dimensioning it with respect to the center. I haven't selected the symmetry line with respect to the center. Now we do know that this is 0.8 as usual. And the overall distance is 3. The 0.8 rib thickness is already given in the notes below over here. Similarly, I do have one over here which is at a distance of 8. So let me try to take that as well in one. I am trying to make all of them in one go because it will be a little more easier for me to work on it. Is this symmetry line? This is actually 10 and it is at a distance of 8 from here. And we know that this is 0.8. Now, understanding the same concept, there is one more here, as you can see. Let me try to do that as well. See, there is a rectangle which should actually go over here, which should again be 0.8, not coincident with anything. The thickness is 0.8. It should maintain symmetry with respect to this center. So there I'll be using references for my feature. And then start using my references because I need to maintain symmetry. Now let's try to maintain symmetry with respect to that line and give the dimensions one after the other. The symmetry line. The overall thickness of this is probably given in the next view or in the first view. It's probably 10 typical. So let me try to take this distance as 10. Maybe 8. It's not properly given in the drawing. Now, I do know that the distance from the center is 6. That is from here to here is supposed to be 6. So I'll give that as 6. Now, I require to add 2 lines over here and then maintain 0.8 again. So I'll just add one, mirror it and then maintain 0.8. This 2 distance 0.8. And then of course to get the arc over here, we need to maintain the arc. Center, start, end. Now let's try to trim off whatever is not necessary over here. The sketch will be completely constrained and once I exit, it will start to add material. Of course, I wanted to add it up to the next surface from the beginning, so it adds it. These are how you make your supports. Now, working on your snap fits. Snap fits are actually starting from 13. I'd like to make this shape later. So from the bottom face, they are at a distance of 13. So let me try to take that as 13 first. On the 13 plane, I'd like to start adding the material and then mirror one after the other. It will be a little more easier for me to do that. Using this as my reference first, I'm trying to make a square. It is actually a square. This symbol represents a square. That means this is 2 and this is 2. Of course, everybody knows that. and it should be at a distance of 12 from here. Let me try to take a reference first and then maintain tendency. It's just not working with the way I normally do. Now the distance from this end to this is supposed to be 12. So this is a little more easier for me to do. Now when I exit, it will automatically start adding the material. Of course, I want to start adding it up to the next. This is the next. I can mirror it first, or let me try to make this particular feature and then mirror it. So to do so, again I'm trying to use my pad command, but instead of selecting the plane, I'm trying to select the front face. Now over here, my references are these as well as the ends of the feature. So I'd like to project all three of them as my reference. And then start working on the shape. Now the shape actually goes like this. I'll give rounds later, and then goes like that till the end of this, and then goes down, small shape this way, and comes down and then closes. I'll try to convert this into a solid shape. Now we can start dimensioning one after the other. This is supposed to be 1.5 and this is supposed to be 0.5, and the distance between this and this is supposed to be 0.7. This is your overall features, and since these and these are in line, we require to give the height. Okay, which is this particular height. Let me try to give this height. Now once I exit, it tries to add the material. We want the material to be added up to the end of the fit. You can see the fit. You can give rounds a little later. You can actually group these two together. You can create it in a new part and then mirror it, or actually you can mirror it directly too. I'd like to mirror with respect to this face first. It tries to create a mirror. Now similarly, I want to mirror this to this face. Okay, I'd like to mirror this with respect to the center. And then similarly, I'd like to mirror this with respect to the center. I can't mirror this as well. Okay, I might have to repeat the same over here because it's not mirroring. Or I'll do one thing. I'll first I'll create both on one side and then work on it. While doing this pad and make a sketch, I'll mirror it onto the other side as well, just to be on safe side. And then start mirroring it. And then I'll take these two and mirror it onto the front side. You get the mirror now. Similarly, while doing the pad, I'll do the same thing. I'll again mirror the sketch. Let me take the front view. I'll mirror the sketch with respect to the center onto the other side. And then of course I'll do the same mirror. It does it correctly. Okay, I think the pad fails. So let me try to redo it here again. The pad is failing. I mean the end condition is failing. So let me try to redo this again. I don't have to do anything. I just have to take the projection of the previous one. So I'll just use projection and take the previous sketch and join whatever is necessary. And join these two. This can be mirrored again onto the other side and do it in one go. While adding, of course, I want to add it till the plane. So let me try to select till the plane and select the face. This is how you work on your snap fit. Normally, you can directly do it in one attempt. But since there is circular feature here, so I required it to be added up to the next. So it took two multiple attempts to do it. Now last but not the least, let's try to give the rounds. Before that, there's a cut over here which I'd like to make using a pocket. Let me try to take the face and use this as my reference. Start making the circle. Actually, I'm taking a semicircle exactly located at the center, and the distance for this is actually 3.5 radius, and cut it. Since we are working on solid modeling, we require to close the sketch and now try to cut it. We can cut it up to next it can find. And saying last but not the least again, let's try to give our rounds. We have our 0.5 which is over here and over here. Similarly, it goes on all the sides over here and over here. And over here too, this is 0.5. And we have chamfer operations which are supposed to be done as well on these edges. So I do have one edge, the second edge and the third edge. The chamfer is 0.6, so let me try to take 0.6 and say okay, this is your chamfer. This is how you make a plastic model with your snap fits and control using surfacing as well as a solid model. We do have advanced level of surfacing training provided at our institute as well. If you're interested, our details are given in the description below. You can contact us. Meanwhile, if you're looking for any specific options, you can comment below. We can work on it and give you more tutorials on those concepts as well. Subscribe to our channel and like our videos. It will give us a boost to post more informative tutorials like these. Thank you.